This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Ever wondered how rainbows actually work? It's more than just a pretty arc in the sky, right?
Absolutely. There's some serious physics behind those vibrant colors.
And today we're diving into a simulator that breaks it all down.
Yeah, it's a really cool tool for visualizing the process.
So let's talk about this rainbow simulator. So this rainbow simulator, it's an online tool, right? What exactly does it let you do?
It lets you manipulate different variables to see how they affect the rainbow's formation. You can adjust the refractive index of light, for example.
Refractive index? Sounds complicated.
It's basically how much the light bends when it goes from one medium to another, like from air to water.
Ah, okay. So changing that changes the rainbow. So if you tweak the refractive index, what happens to the rainbow? Does it change color?
It does. Changing the refractive index shifts the wavelengths of light, which directly affects the colors you see. It's like tuning a musical instrument.
So it's not just about the water droplets, it's also about the light itself.
Exactly. The light's properties are key to understanding how the rainbow forms.
The simulator also lets you move light rays around, right?
Yep, you can drag them to see how their path changes as they refract and reflect within the water droplets.
So it's a really hand-on way to learn about refraction and reflection.
Exactly. It makes the concepts much more intuitive.
I also noticed something about real intensity ratio and cross-section. What's that all about?
Those options show you the intensity of the light at different points and the area where the light is refracted. It gives you a more detailed picture of the process.
So it's like zooming in on the physics behind the pretty colors.
Precisely.
This simulator was created by Fu-Kun Wang, Fremont Tank, and Lookbang, right? Impressive team effort.
Definitely. It shows a great understanding of both physics and interactive design.
And where can our listeners find this amazing rainbow simulator?
It's hosted on iwanttostudy.org. It's part of a larger collection of educational resources.
So a great resource for anyone interested in learning more about rainbows and the science behind them. Speaking of iwanttostudy.org, that website seems to have a lot more than just rainbow simulators.
It's a treasure trove of interactive physics simulations covering a wide range of topics. It's a great resource for student and teachers alike.
So it's like a one-stop shop for interactive science learning? I saw some other simulations mentioned, like one about ball tosses and another about variable resistors. What's the common thread?
They're all interactive simulations designed to help students visualize and understand complex physics concepts in a fun and engaging way.
So it's all about making learning more accessible and enjoyable? The website mentions open educational resources. What does that mean?
It means the resources are freely available for anyone to use and adapt. It's all about promoting open access to education.
So anyone can use these simulations for learning or teaching? And what about licensing? Are there any restrictions on using these resources?
They're licensed under Creative Commons, which means you can use them for non-commercial purposes. For commercial use, there are specific guidelines to follow.
So it's pretty open, but there are some rules for commercial use, right? So to wrap things up, this rainbow simulator is a fantastic tool for visualizing a complex scientific phenomenon.
Absolutely. It's a great example of how interactive simulations can make learning more engaging and effective.
And it's just one of many great resources available on iwanttostudy.org. That was a great discussion. Thanks for sharing your insights.